So in this problem, we're asked to find the shortest distance between these two lines. And we've put them in terms of xyz and sub t over here, and then xyz of s over here. And when I subtract these two, I'm going to get vector pq. So we'll go ahead and do that. Negative 3s, this is pq is going to be equal to vector negative 3s, and then plus 7t minus 11. I'm just subtracting this minus that, and then we're going to have the same thing, this minus that. So we get s plus 6t plus 2, and then we're going to have this minus that is actually 9t. So that's going to be vector pq. Then I'm going to want to take the dot products, because look, if I want to find the shortest distance, then these 2 points have to be perpendicular, right? And so I need to find the dot product of PQ with the normals, or sorry, the direction vectors that we had over here. So we do PQ dot A naught, B naught, C naught. That's supposed to equal to 0 to make it perpendicular 90 degrees. And then we do PQ dot A, B, C equals 0. And that comes from these. So we're going to do A naught, B naught, C naught, or A, B, and then C is going to be 0 there. We're finding the direction vectors of those two, dotting that with the PQ that we just found. And that'll help us find this. So let's just go ahead and do that. The first dot product is going to be dotted with this one. That's going to be negative 7, negative 6, and negative 9. And then the next dot product is going to be dotted with negative 3, 1, and then 0 over there. That's just the direction vectors of those. So let's do that. We get 21s minus 49t, and then plus 77 in the first one. And this is a dot product, so we're going to parentheses and then add everything up. Dot product here is going to be negative 6s, and then minus 36t, and then minus 12. And then for this last one, it's just minus 81t. This is supposed to be equal to 0, because that's what that says. So we could start to simplify this a little further. We're going to say that 15s, and then we can add up all the t's here. We're going to get minus 166t, and then we're going to get plus 65 here in the end. And then we could say equals 0 for that one. And then we'll go and get the second one, which is this one. We're going to dot this with that, this with that, and this with that. So we're going to get 9s minus 21t, and then plus 33. And then this is going to be added with s plus 6t plus 2, and then 0 over there. This is supposed to be equal to 0. We'll simplify this into 10s minus 15t, and then plus 35. And so we can multiply both of these by, let's say, negative 3 over here and 2 on this side. So we're going to get 30s minus 332t plus 130. That's equal to 0. And then over here, we're going to get negative 30s plus 45t, and then minus 105 equals 0. We can add those together, and we're going to get negative 287t plus 25 is equal to 0. And of course, this will simplify to 25 over 287 for t. And this is great. Now, we could do the same thing for s over here, and we can get 10s minus 15 times 25 over 287 plus 35. And then simplifying down this equation, we'll get s equals actually negative 967 over 287. Yeah. Now we're going to plug this into our equation for PQ over here. But when we do that, we're going to take the magnitude, because we actually want to find the magnitude. That's just going to be the distance. So we're going to square all these things and then square root everything. So we can find that in one line. Negative 3, and I'll make a big bracket here, because we got negative 6. 967 divided by 287 plus 7 times 25 over 287 minus 11. And then we're going to square that. Then we can add in the next one. This is going to be s negative 967 over 287 plus 6 times 25 over 287 plus 2, square that, plus 9 times 25 over 287 squared. Then we're going to square root that whole thing, and we should be able to get that in one line on the calculator. So we'll say something like negative 3 times negative 967 over 287 plus 7 times 25 over 287 minus 11 squared, and then plus negative 967 over 287 plus 6 times 25 over 287 plus 2 squared plus 9 times 25 divided by 287 squared. And then I'm going to be getting 405 over 287. We're going to take the square root of that, which is going to equal 1.188. And that is indeed the correct answer. So that would be the shortest distance between those two lines. And there's a lot of different ways to rewrite this. So, but yeah, this is the correct answer. It's pretty crazy. Remember this expression right here, doing the dot products and then finding the magnitude. It's not too bad, pretty easy.